The last section is solving. We have a mix of logarithmic and exponential equations that we're going to solve, and we want to make sure that we show any work that we have to do to get our answer. So in the first one, you notice that both of these sides have a log base 3. So it's kind of like when we were rewriting our exponentials. It's not that these cancel out, it's just that we don't use them to solve for what x is. So we just use this part right here. So we would have 4x is equal to 12. We're going to divide both sides by 4, and so x is equal to 3. On the next one, you notice that we have 2 logs on one side, and those 2 logs are connected by addition. So anytime that you have 2 logs on one side that are connected either by addition or subtraction, that's going to be one where we need to condense first. So when we condense, these 2 logs combine into 1. So this would just be log base 4. And then these 2, since this is addition, these 2 become multiplication. So this would be log base 4 of 5x is equal to log base 4 of 20. So again, we can see that we have a log base 4 on both sides. So they don't cancel out, we just don't use them to figure out what x is. So we just bring these 2 parts to figure out x. So we have 5x is equal to 20. We're going to divide both sides by 5, and we get x is equal to 4. On the last one, we only have 1 log, and it's a log base 5. So anytime that you have 1 log, probably the easiest thing to do, there's 2 ways that you can think about it. Whatever this base is down here, we can use that as the base for our exponential. So these 2 would cancel out, so x is equal to e to the power of 5. Or you can rewrite it. So ln of x is equal to 5. We know that the base here is e, so e would become the base for our exponential. Go around the equal sign, so this is our exponent, and this is equal to x. So there's 2 different ways that you can think about that, but they both will work. All right, on number 31, we have 2 logs. They're on the same side. They're being connected with addition. So this is another one where we need to condense before we can solve. So both of these 2 logs, log base 5s, are going to condense into 1. So we have log base 5, and then these 2, since their logs are connected by addition, these 2 are going to get multiplied together. So this is x plus 3 times x minus 3, and it's equal to 2. So the first thing I want to do before I do anything else is I want to simplify this part. So if you remember, we've done this a little bit before, where we have x plus 3 and x minus 3. So x times x is x squared, x times 3 is 3x, and that's positive. Negative 3 times x is negative 3x. Negative 3 times positive 3 is negative 9. Combining like terms means that these 2 will cancel each other out. They add to 0. So really what we're left with is just x squared minus 9. So this is the same thing as log base 5 of x squared minus 9 is equal to 2. I only have 1 log, so I can either raise this as the exponent with the power of 5, or we can rewrite it. But either way, what we'll end up with is 5 squared is equal to x squared minus 9. Five squared is 25. So to get x squared by itself, we're going to add 9 to both sides. So x squared is equal to 34. To undo squaring, you have to do the square root, and so x would be equal to the square root of 34. On 32, we don't have any logs, so this is an exponential equation. And the very first thing we want to look at when we're solving an exponential equation is whether or not we can get our bases to match. So if I look at the 9 here and the 27 here, these are both powers of 3. So 9 is the same thing as 3 squared, and we still have that x minus 1. And 27 is the same thing as 3 cubed with 2x out here. So now that our bases match, we don't need to use them to solve for x. We're just going to make sure that we multiply these two together and multiply these two together. So 2 times x is 2x, 2 times negative 1 is negative 2, and 3 times 2x is equal to 6x. So we have x's on both sides. Start with your smallest variable. So negative 2 is equal to 4x. We're going to divide by 4 on both sides. So x is equal to negative 1/2. On the next one, we always need to isolate the part that has the x first. That should always be our first step. So again, we're working with an exponential function here. So we're going to subtract 4 from both sides. And so we get 10 to the power of x is equal to 5. So in order to figure out what x is equal to, we need to take the log on both sides. So we're going to take log on this side, and whatever we do to one side, we have to do to the other. And when we do that, remember, this is the power rule, that x is going to become the coefficient. So this is going to be x log of 10 is equal to log of 5. To get x by itself now, we just have to divide both sides by log of 10. These two are going to cancel out, and so we have x is equal to log of 5. Why don't I have anything right here? Well, log base 10 of 10, that's the same thing as 1. So really I didn't even need to do anything over here because this log base 10, that would cancel out as well. So really we can go from here to knowing that x is equal to log base 5. All right, on the next one, we have log of 8x is equal to 1. So we have one log, and the base is 10. So this is really log base 10 of 8x is equal to 1. So because there's only one log, the easiest way would either be to make this a 10 down here, or we can rewrite it. Either way, you're going to get the same thing. So this is 10 to the power of 1 is equal to 8x. 10 to the power of 1 is just 10. So 10 is equal to 8x. Divide by 8. X is equal to, we're going to reduce this fraction. This would be 5/4 or 1.25. Number 35. Okay, I don't have any logs here, so the first thing I want to try and do with an exponential is rewrite these so that they are the same power. So 4 is a power of 2, and we still keep the 2x, and 32 is a power of 2, and we still keep the x plus 3. Our bases are the same. It doesn't mean that they cancel out, it just means that we don't use them to solve for x. So we need to multiply these two together and multiply these two together. So we have 4x is equal to 5x plus 15. So I'm going to subtract 5x from both sides. And I'm going to end up with negative 1x equals 15 on this side. So we're going to divide by negative 1. So x is equal to negative 15. On the last one here, if we can't get these two bases to match, then we just need to take the log on both sides. So we have log of 3 to the power of x is equal to log of 10. Log of 10, this is log base 10 of 10. So the base here and the number here match, which means that this is going to be equal to 1. The exponent over here, this is the power rule again, becomes the coefficient out here. So x times log of 3 is equal to 1. To get x by itself, we're going to divide both sides by the log of 3. And so x is equal to 1 over log of 3. All right, for the last 3, these are all exponential, but they have multiple steps. So the very first thing that we always want to do is we want to make sure that the part that contains the exponent is isolated first. So in this one we have 12 is equal to 3 times 5 to the power of x. Well, we want to make sure that we get the 5 to the power of x by itself first. So we need to divide both sides by 3. So we get 4 is equal to 5 to the power of x. Now, because it's an exponential, the first thing we want to try is to get our bases the same, but I can't write 4 and 5 as the power of the same number. So we're going to have to take the log on both sides. So we have log of 4 is equal to log of 5 to the power of x. Remember that the exponent here, because of the power rule, becomes the coefficient. So this is log of 4 is equal to x times log of 5. To get the x by itself, we're going to divide by log of 5 on both sides. And that tells us that x is equal to log of 4 over log of 5. And the next one, again, what we're trying to do is we're trying to isolate the part that has the variable. So we want to get this e to the x plus 2 completely by itself first. So if you think about this as 3x minus 4 equals 11, then it might help you figure out what your first step should be. So we're going to add 4 to both sides. So we have 3 times e to the power of x plus 2 is equal to 15. And again, we're trying to isolate this part. So if we had 3x is equal to 15, we would divide by 3 next. So e to the power of x plus 2 is equal to 5. And I can't write e and 5 as powers of the same base, so we're going to have to take the log on each side. And in this case, because it's e, we're going to use ln. So we have ln of e to the x plus 2 is equal to ln of 5. So remember that this exponent, because of the power rule, comes out front. And ln is a log base e, and e have the same base. So really, this part is going to cancel out, and we get x plus 2 is equal to ln of 5. To get x by itself, we subtract 2 from both sides. So we get x is equal to ln of 5 minus 2. Last one, we have 4 to the power of x minus 2. So again, we're trying to isolate this piece right here. So we're going to add 2 to both sides. And we have 4 to the power of x is equal to 32. This time I can rewrite these so that they are both powers of 2. So 4 would be the same thing as 2 squared. Not 2, that's an x. And 32 is the same thing as 2 to the power of 5. So now that our bases match, they don't cancel out, we just don't use them to find out what x is. So this would be 2x is equal to 5. Divide both sides by 2. X is equal to 5 halves.